When we look up at the night sky, it seems calm and unchanging, but the universe is anything but still. Stars are born, live and die, sometimes in spectacular explosions that can outshine entire galaxies. These cosmic fireworks, novae and supernovae, are not just beautiful, they're essential to the universe's evolution. The iron in your blood, the oxygen you breathe, the calcium in your bones, all were forged in stars and scattered by these explosions. Studying novae and supernovae means exploring the origins of the elements that make up planets, life, and even ourselves. Ancient astronomers saw these sudden, brilliant guest stars as omens, but today we know they're natural, awe-inspiring events. The energy released is almost unimaginable, a reminder of the universe's raw power. But what exactly are these brilliant flashes? Novae and supernovae are both stellar explosions, but they're fundamentally different. One is a recurring surface eruption, a stellar hiccup. The other is a final, cataclysmic act of self-destruction. To truly appreciate the universe, we need to understand the difference between these two phenomena. Let's dive into the heart of these cosmic explosions, starting with the less violent but no less fascinating nova. Get ready for a journey into the universe's most dramatic events. A nova isn't a new star but a sudden brightening of an old one in a binary system. Here, a white dwarf, an ultra-dense stellar remnant, pulls gas from its companion star, forming an accretion disk. Over thousands of years, hydrogen piles up on the white dwarf's surface. When the pressure and temperature get high enough, a runaway thermonuclear reaction ignites, a massive surface explosion. The blast ejects the accumulated gas into space, making the star shine up to hundreds of thousands of times brighter. Remarkably, the white dwarf survives, ready to repeat the process. Novae can recur, with the white dwarf siphoning gas and erupting again and again over cosmic timescales. It's a cycle of theft, accumulation, and eruption, a dramatic but sustainable process. These recurring outbursts are a testament to the dynamic relationships between stars. Novae are cosmic reminders that even old stars can put on a spectacular show. But what happens when a star's end is truly final? Enter the supernova. If a nova is a stellar hiccup, a supernova is a star's final scream, a cataclysm that destroys the star. There are two main types, one from massive stars and one from white dwarfs pushed to their limit. In a Type 2 supernova, a massive star burns through its fuel, forms an iron core and collapses under gravity, triggering a colossal explosion. The blast can outshine an entire galaxy, releasing more energy in seconds than our sun will in its lifetime. In a Type Ia supernova, a white dwarf in a binary system accumulates too much mass, crosses a critical limit, and detonates in a thermonuclear explosion, leaving nothing behind. Both types are among the most energetic events in the universe. Supernovae mark the ultimate end for stars, scattering their elements across space. These explosions are the engines of cosmic transformation. Novae and supernovae may both be stellar explosions, but their differences are vast. A nova is a surface eruption on a white dwarf in a binary system, fueled by stolen gas, a recurring event. The white dwarf survives, ready for another round. A supernova, by contrast, is the total destruction or collapse of a star, an internal process with no return. In a Type 2 supernova, a massive star's core collapses, leaving behind a neutron star or black hole. In a Type Ia, the white dwarf is obliterated, leaving only an expanding cloud of gas and elements. Novae are about survival and repetition, supernovae are about finality and transformation. The mechanisms are fundamentally different. Novae are external, supernovae are internal. This leads to differences in brightness, frequency, and the elements they create. Novae are like firecrackers, supernovae are nuclear bombs. One is a cycle, the other a one-time cosmic event. Understanding these differences reveals the true drama of stellar evolution. Now let's compare their scale and impact. The energy difference between a nova and a supernova is staggering. A nova can shine with the light of 100,000 suns, an impressive outburst, visible for weeks. But a supernova can be 10 million times brighter, outshining its entire galaxy and releasing as much energy in seconds as the sun will in billions of years. If a supernova occurred as close as Proxima Centauri, it would be brighter than the full moon. Novae are relatively common. Dozens occur in our galaxy each year, though many are hidden by dust. Supernovae are rare, happening only once or twice per century in a galaxy like ours. Their rarity makes each one a precious opportunity for astronomers. Novae are regular fireworks. Supernovae are rare, universe-shaping events. Both light up the cosmos, but on vastly different scales. Their frequency and power shape the story of our galaxy. The aftermath of these explosions tells us as much as the events themselves. After a nova, the white dwarf survives, shedding a glowing shell of gas, a nova remnant that fades over thousands of years. The cycle can repeat, with the white dwarf ready for another eruption. Novae are about continuity, a sustainable, dramatic relationship between stars. Supernovae, however, leave behind transformation. A Type II supernova's core collapses into a neutron star or black hole, while its outer layers form a vast, long-lasting supernova remnant. Type Ia supernovae leave no star behind, just an expanding cloud of elements. These remnants, like the Crab Nebula, are cosmic laboratories for studying the elements forged in the explosion. Supernovae are the primary source of all elements heavier than hydrogen and helium. The carbon, oxygen, and iron in our bodies were created in these blasts. The aftermath of a supernova seeds the galaxy with material for new stars and planets. These explosions are not just endings, they're beginnings for the next generation of cosmic objects. The cycle of creation continues. Novae and supernovae aren't just distant spectacles, they're fundamental to our existence. These explosions create and distribute the elements that make up planets, life, and even our own bodies. Novae reveal the physics of binary stars and extreme conditions on white dwarfs. Supernovae answer the question, where do the elements come from? The calcium in our bones and iron in our blood are the legacy of ancient stars. Type Ia supernovae serve as cosmic measuring sticks, standard candles that help us map the universe and discover its accelerating expansion. By studying these explosions, we piece together the story of the cosmos and our own origins. The next time you look at the stars, remember, you are made of stardust, born from the universe's most dramatic events. These explosions are not just endings, but the start of countless new stories, including ours. The universe is alive with creation, destruction, and renewal. By understanding novae and supernovae, we uncover the deepest roots of our existence, and that is truly wondrous.